Hello everyone, my name is Chris Murray and I'm a technical marketing engineer here at Network to Code, and today we're going to be taking a look at workflow automations. I'll show some examples and then we'll take a look at some workflows in the real world. So let's get started. In our first example here, we have self-service portals. Some of the benefits of self-service portals are that they save engineering hours, they deliver services more quickly, and it allows the requester to define exactly what they need, minimizing the opportunity for miscommunication. These benefits are achieved by automating workflows that would otherwise be performed by engineers. Now, some of the use cases would be customers, non-technical employees, and vendors submitting self-service requests to perform actions like employee provisioning, whether that's turning up new ports or configuring authentication systems, etc., or simply generating reports. Technical personnel also use self-service portals because it saves them time. By performing actions via portal, they no longer are required to log into multiple systems and perform their own quality assurance tests. The automations can take care of that for the engineer. Now, in our next example here, we have self-triggering automations, which occur when a specific event happens. For example, in the event of a circuit failure, the monitoring system would trigger an alarm, and then this information would be forwarded to an automation engine, which would then perform an exhaustive series of tasks that would normally be very time-consuming. This is going to save engineering time, but also expedite the response to critical failures to get your network back online and functional more quickly. Now, in our next example, we're going to be talking about how we use automation to reduce environmental complexity, specifically as it relates to device configurations. Now, most engineers are familiar with drafting a design template and then using that template to configure devices as they're deployed to the network. And that's how it should be done. On day one, the network is very standardized. However, as the years progress and remedial actions are taken on those devices to address the problems of the present, and as changes are executed against the network, some approved, maybe some aren't approved, they're not being applied uniformly across the environment. So what ends up happening is it generates variants of that original design template, and then the variants get adjusted. What ends up occurring is you have all these configurations in your network that no longer represent the original intent. With so many disparate and unfamiliar configurations in the environment, network behavior becomes unpredictable, management tasks become more burdensome and time-consuming, the outages that occur are more frequent and longer, and you've introduced new security gaps and vulnerabilities which make your network more susceptible to attack. Now, this problem can be solved with a solution such as Nautobot's Golden Configuration application, which provides a means to maintain your network configurations to a standard, identify when deviations have occurred, and then to correct those deviations programmatically. Now, this is accomplished by leveraging the information in the network source of truth to generate an intended configuration, and then comparing that configuration to the live configuration on the device. When discrepancies are identified, it's brought to the attention of administrators so that they can choose whether to remediate that problem with a single click or have them remediated automatically in the future. The result is a network where all the devices conform to a nuanced standard, which results in a more stable, reliable, and secure network. Automation also makes it possible to fully provision networks with very little human intervention. Now, this can be accomplished in Nautobot. Network architects define reusable models of network segments, and network operators define the parameters and attributes of those network segments, like location, rack size, and function. And then Nautobot leverages the model parameters and attributes and the source of truth data to populate Nautobot. Once the physical devices have been deployed and they're reachable, zero-touch provisioning handles pushing the full functional configuration to the device. In addition to that, Nautobot is able to configure the IT management systems accordingly. For example, IPAMs, CMDBs, and monitoring systems. Quality assurance checks then ensure that the provisioning was successful, performing tests such as verifying reachability, functionality, and performance. Lastly, a report could be generated which could be provided to stakeholders. That would include things like the site name, the deployment type, the deploying engineer, the results of quality assurance checks, the devices that were provisioned, and any other information that stakeholders might find valuable. Automation also provides high repeatability and scalability. For example, when transitioning to new models, technologies, and vendors, the attributes and specifications of the previous build inform the new build. Topological and syntax differences are accounted for programmatically, while Nautobot inventories the new device as part of the onboarding process. Automations also streamline the process of cloning devices, racks, and locations. Automations can be used to populate the attributes of newly provisioned network segments and automatically generate their network configuration. In our last example, I want to show how automations can be used to resolve tickets automatically by analyzing the fault, determining the remedial steps, and executing them without human intervention. Solutions like this resolve tickets before they're seen by humans. With the right solution in place, your engineers will spend 50% less time resolving tickets, and common issues will be resolved more quickly, with a higher degree of consistency in the closure and remediation codes, which is going to aid in reporting. Even in the event that a ticket cannot be resolved, automations can provide robust diagnostic data that enriches the ticket, which enables human engineers to understand the nature of the problem more quickly. Now that we've seen some examples of what network automation can accomplish, let's take a look at those automations in the real world. In our example here, we have a global banking company who virtually everyone is familiar with, leveraging Nautobot to be more efficient. Now the challenge here was that they had an expanding customer base and evolving customer expectations that created an increased demand for network services. The legacy practices they were using, such as hands-on keyboard task execution and manual record keeping, was simply insufficient to keep up with this new demand. Project delays started to mount as engineers had to sift through duplicate records, resolve discrepancies, and search for omitted information. And the manual process management methods contributed to these delays as well. Requests would frequently sit for days before an approver or engineer performed a simple administrative task. It was time for a new data-centric and efficiency-minded approach to increase the project's throughput. Now, Nautobot was introduced as a single source of truth, which provided a means to centralize network data and streamline business processes. Additionally, several applications were integrated into the solution as well. Our single source of truth application facilitated the exchange of information with other systems at the bank. The data validation application ensured that information being consumed and distributed was standardized. A custom firewall application was leveraged to evaluate the risk of new rules being submitted. A custom device lifecycle management application assisted the bank in projecting the future costs of network refreshes. And lastly, a golden configuration application was integrated to help the bank maintain configurations throughout the bank. Through the use of these tools, the bank was able to achieve a 35% reduction in time spent on analytical processes. Furthermore, they were able to reduce the time spent on deploying new equipment from weeks to hours. Lastly, this solution brought consistency to their data ecosystem and removed the manual efforts involved with distributing that data. If you're interested in learning more about what this bank was able to accomplish with Nautobot, there's a link below to the full case study. These examples illustrate just how effective network automation is at transforming network management, enabling faster delivery, reduced risks, and more efficient operations. Thank you for joining me today.